member. Hello and good morning from the East Coast, everybody. I just wanted to give you a quick update. We're going to wait one additional minute here. We've had some people send me and ask for some help logging on. We're going to give them an extra minute to log on, and then we'll begin the presentation. Thank you very much. Okay, welcome and good morning, and thank you for joining us here on another automation webinar with Phoenix Contact. Thank you very much for taking time out of your day to join us. A little bit of information before we start the webinar. My name is Zachary Stank. I'm hosting this webinar, and today our presenter is Jason Haldeman. Jason is a senior product marketing specialist for Serial and IO products at Phoenix Contact USA. I want to let you know that we are broadcasting live, unless you're viewing this as the rerun channel. So if you use the link that was sent to you, you can view this webinar at any time in the future. And if you forget that link or lose the link, you can always sign back up through our 2021 automation webinars website where you did this before. So a quick information for everybody that's attending. We will be using obviously audio through the computer to communicate. It is a one-way communication, so you cannot send audio through. We can't hear you, but there is a Q&A that is available. So if you have a question about a product or a slide, a technology, please don't hesitate to put that in the Q&A. We will get to Q&A as quickly as we can, but please know that there is a 20-second delay between our what we say and what you see on your screen. So if you put in a Q&A on a slide and we bypass it without saying anything, we're not intentionally trying to skip you. It may just be, you know, that 20-second delay has taken over. And at the very end, we have built-in time to go through and answer any Q&A that has come up. So please, at any time, feel free to answer questions. I'll be monitoring the Q&A, and if time allows it while Jason is presenting, I will ask him questions as they pop up. All right, and without further ado, I appreciate you everybody here being online and being live with us today. I want to welcome Jason Haldeman, who's going to lead us through here today. Take it away, Jason.
Thank you, Zach. All right, my name is Jason Haldeman. I am the Senior Product Marketing Specialist here at Phoenix. My main focus is our serial communications and our IO products. And that's kind of the focus here for today's discussion. And what we really want to get into is some of the basics and the basic understanding of what IO Link is. IO Link is really, it's been around for quite a few number of years. It's taken a little bit while to take off, but over the last 2 or 3 years, it's really becoming a hot topic, a hot item that everybody's hearing about. Everybody's hearing devices that support this protocol, but there's still a lot of confusion of exactly what IO Link is and what I can use it for, or how I can really implement this into my applications and take full advantage of it. So the first thing to understand is IO Link is an official standard. It's not something proprietary done by one specific vendor. It is an open standard, and as you can see, there are quite a few vendors that are a part of this standard, And the idea is just to create a concept across different sensor and IO manufacturers to support this new protocol and this communications. And to give a quick intro into it, I've pulled a video. The video is from the official IO-Link organization. So I figured we'll start off by running through this first and then dive into the technology as an intro.
Whoops. I don't believe we're getting any audio out of that, Jason. So why don't you hit pause real quick?
All right.
Let's see if we can get that fixed for you.
Let me stop sharing. Share. How about this time?
You're wondering what IO-Link is? Yeah. What it can do? How you can benefit from it? Exactly. Yeah? Well then, listen up. Okay. You work with sensors. Yeah. With actuators. Exactly. You're having difficulties establishing contact to both of them at the field level. How did you know? You have no communication between the field level and the control level. Down to the last meter, you can't even see your sensors and actuators anymore because of all the cables. Don't tell me about it. You've often grabbed the screwdriver only to rub your hands raw. And it hurts. You've grown tired of having to shut down half of the company just because a sensor is acting up. And so you're fed up with configuring your sensors and actuators based on rule of thumb estimates. Exactly. But you'd like to know how your sensor is doing at all times. You know, what it's up to at the moment. Oh, yeah. And particularly how long it can keep going. You said it. In this case, before it's too late. Oops. In short, you're increasingly frustrated that your sensors are doing work that can't be monitored. That they do what they want, not what you want. Exactly. It doesn't have to be that way, because now there is IO-Link. With IO-Link, that famous last meter becomes a racetrack for data, facts, information, and commands. That's interesting. IO-Link turns your sensors and actuators into true chatterboxes. IO-Link turns sensors and actuators into co-workers who do what you tell them. Oh, finally. And if you want a sensor to do something else, you can change the parameters while the system is still running. Really? That's great. And you want to know how the wiring works? Okay. If you can do this, then you're perfectly capable of installing IO-Link on your devices. But that's easy. It saves time. Spares your nerves. Oh, my nerves. And cuts back on sensor types. Hey. Not to mention the new possibilities it opens up for machine design. Hey. That's IO-Link. Universal. Smart. Easy.
All right. So you could say it's a nice little intro video to bring into the idea, the concept behind this. If you notice from the video, they covered a lot of stuff, but the main idea is sensors are getting more and more complicated. There's a lot more information that their sensors are able to provide from us. And with this complication in the sensors, there needed to be a mechanism to configure and to set up a sensor. That was kind of the idea that was behind the birth of IO-Link, was there needed to be a way of communicating to the sensor to set up and do the initial configuration. Now, we've all had sensors and we've all opened the box and gone through the rotary switches that they've put on the top to go through the different settings and the registers to configure the sensor for what we need. But the problem is once that sensor, or if that sensor fails down the road, you need to have somebody come back and go through that configuration and those settings again. This is time, and this is complicated because somebody has to keep a record of this. And the idea behind IO-Link originally was that this is going to be a communications protocol that allows us to communicate down to the sensor to configure it. So this allows a simple universal configuration of a sensor through the actual wiring of the sensor connection itself, because another part of it is they didn't want to have to add an extra connector onto the top of the sensor as a configuration port. So what we're doing is we're taking the traditional digital line and turning it into a communications protocol, basically sending like Morse code down the line to communicate to the sensor to do this initial configuration. So when this concept started, it was deemed that first we need to have what they call an IO link master. This is the device that's going to communicate to the sensor and provide and understand this IO link communications, basically turning that digital line into a line of Morse code so that we can send information and receive information from the IO link device. The IO link device is the physical sensor. It is the device on the other end of the connection. Then you have the physical cabling. This was a very important part of it, is they wanted this communications protocol to travel over the cable you already are using to communicate with the sensor to get your 24-volt signal to sense whether a device is there or not. So there's no cabling changes, there's no specialty cables. It is the standard 3-wire or 5-wire sensor cable you're using today, and you're just simply enabling the communications to travel across that line. And then last, there needed to be a mechanism to allow vendors from different products from different vendors to be able to work with each other. So they created a concept called the IODD. This is the description file. This is the file that contains all the settings that my sensor supports. Some sensors require little or no configuration. Some sensors could require a lot of configuration. This IODD file, which is in an XML format, provides the information or a description of what settings the sensor has so that I can load it into some software tool that'll allow me to talk to the sensor, and I can go through and do the initial configuration of the sensor to figure out what type of data that I want to get from the device and get it into the network. So if we look at it.
Hey, yeah. Jason, do you have time for a quick question?
Sure.
So the question in chat is, the IODD file, is that something that the user develops, or is that developed by the manufacturer?
That is developed by the manufacturer of the sensor. So the sensor manufacturer provides an IODD file to go along with their sensor for the configuration. It's very similar to the concept if you're familiar with Ethernet IP. Phoenix makes an IO device. We provide an EDS file that can be used for the integration into the Ethernet IP network. Same thing. This is an IODD. This is the configuration file that whoever makes the sensor will supply to the manufacturer, or you can pull from them to go to do the configuration. So no, you don't have to create this yourself. And also, it is good to remember that while these files are used for the initial configuration, they are not always a complete requirement, and you'll see why here in some of the next couple of slides. So the first part of the standard, of course, is the cabling or the wiring. The idea behind this is most sensor cables have M12 connectors on it. So with the M12 connection, they kind of focused on the different types of wiring connections you have with a standard M12 sensor. So you can see IO Link supports 2 different types of ports, what they call their port class A and their port class B. Port class A, which is the traditional IO Link sensor port, you'll see has your pin 1 is your power, pin 3 is your ground, and then pin 4 is your actual IO Link line. This is the line that 90% of the time was probably just going to be used as a digital input or digital output, but that you can activate IO Link communications on that line to then be able to transmit data through. And as part of the standard, there is one pin that's not used, which is pin 2. This is open to the manufacturers of the IO Link master to decide what they want to use with that. Some people make it a configurable IO point or lock it in as a digital input. On top of that, they created a concept for a class B port because they realized that some of these sensors that we're connecting to may have additional power requirements. They may need additional power for the type of things that they're driving. So a type B port is just simply adding an additional 24-volt and ground connection to supply the line. So you still have your standard power on pins 1 and 3. You have your IO Link signal on 4, but now we're taking pin 2 and 5, and we're giving an extra 24-volt 2-amp power to supply the device that's connected to it. So it's just a simple power connection. So a type B port can be used for a type A device if it doesn't require that because it wouldn't be using those pins anyways. So it's just a variation in the standard for power requirements. And then, of course, again, the IODD file, we talked about this a little bit in the original intro, but you can see there is as part of the standard, there is a format to this file, and that the way the data and the sensor manufacturer needs to set up their IODD file. So that any software, the idea behind it is that if Bob Sensor Company has a software tool that imports IODD files to configure Bob sensors, if Tom Sensor Company has a sensor, they can use Bob's software with Tom's EDS or IODD file to configure it. It's just a way of making it universal so that it can be used across different masters or devices. They wanted to create this because we don't want to lock the standard in that you have to use a specific vendor's software tool or utility to configure the devices. And now to kind of step back and look at it, we talked about that you have the master, and then you have the IO-Link device that you're communicating and the sensor cable going between it. Now let's go back and look at the master. So when we indicate a master, a lot of people's thoughts immediately go to, oh, a master, that's a PLC. With IO-Link, it's not a PLC. It's actually just an IO device that contains a little bit of a brain to be able to understand the basic IO-Link communications. So in this example here, I'm going to just go through a standard IP67 IO-Link master. The IO-Link master as part of the IO-Link standard, they understand that not every device you're going to connect to this module is going to talk IO-Link. There's a lot of sensors out there that are just standard DIs and standard DOs. So as a part of the IO-Link standard, the IO-Link port should be able to turn itself off and just be a standard DI or a DO. So what I'm going to kind of go through here is just walk through the idea and walk through an application as to how or why I would use an IO-Link master versus a standard IO module. So if you look here, we have a little example here of the Phoenix IO-Link master. This is pretty much standard for anybody's IP67 IO-Link master that's out there in the market, but it's the same concept behind it. We know we can use IO-Link to communicate to IO-Link sensors, but what else can we do for it? What else does this communication allow us to do? So here, to kind of start off the idea behind it, we have an IO-Link master in the Ethernet in an Ethernet IP variant. List price, let's say it's approximately in the market $450 for this IO module. To do a comparison to a standard digital IO module, here's a module that has 8 inputs and 8 outputs, you're running about the exact same price. So if you're thinking about, do I have IO-Link now or do I need it in the future, but you don't want to add the extra cost, part of the idea is, and part of the standard was they didn't want to add a lot of cost to that. They just wanted to add features and not really an additional cost behind it. So you'll see the prices are pretty much lined up versus standard digital and an IO-Link master. But inside the IO-Link master, we can do so much more. So step one, in this example, I have an 8-port IO-Link IO card. So what can I do? Well, I can go to channel 1 and I can go into the software utility and basically dictate that I want channel 1 to just talk as a standard digital input module, because on this port, I just have we'll call it a dumb sensor, a generic sensor that doesn't support the IO-Link communications protocol. So I'll set that channel for a DI. Then on channel 2, I have a digital output. So I'll go ahead and configure channel 2 to a DO. All right, so this module acts just like a lot of the modules you see in the market where I can configure the channel as a DI or a DO. But then this is where the IO-Link comes in. Now I could go into it and I can actually enable IO-Link on a specific port. So I'm telling this module that the device that's connected to it, 99% of the time, it's just going to be a DI. But I want the module to know that this sensor also supports IO-Link. Well, I don't only need IO-Link to configure the sensor when I first set it up. And I could have done this with, if I had Bob's sensor, I can use Bob's software to set up this sensor. Then when I connect the sensor to my IO-Link master, I just need to continue to talk to it like it's a standard DI sensor. But by having IO-Link activated in the background allows the sensor to send me alarms or send me messages if something is going wrong. You know, that the whole idea or the concept that when the sensor knows it's at its last leg and it's about ready to stop working anymore, it can transmit that line, or it can activate IO link communications across this yellow line, across the standard sensor cable, and say, I need to tell you something. IO link communications will enable and turn on, and it can broadcast a message back to the IO device to tell me what's wrong. Another cool feature, another part of the IO link standard, is that this sensor has a configuration. I took Bob's sensor and I configured it with Bob's software. But now if that sensor fails, I have to replace that sensor and I have to reconfigure it. As part of the standard, my IO link master, when it connects to this device, I have the ability, while I didn't configure the device, I have the ability to take its configuration, read it in, and store it in the IO module's memory as a backup, so that if this sensor does stop working, I could throw it out, put a new sensor on, and then take the backup configuration and push it out to the sensor, and I'm up and ready to go. This is a huge time saver inside of the system. And this is easily done by just manipulating a bit of data saying, yes, read in the configuration. And then there's an alarm to tell me, oh, I have a new sensor. This sensor has no configuration. And then my master can then go, oh, here's your configuration. And we're up and running again. No more configuration of the sensors. No more having to remember how to configure them because it's all stored and backed up in the master. So that's their first advantage of having the IO link master. And then the second, maybe I have a device or an IO link sensor or sensor out there, and I want to get more than just 1 bit of data. IO link actually opens up a communications channel that allows me to send up to 32 bytes of data. So if I have a device out there that needs to send more information than a bit, I can open up IO link, allow it to run all the time, and only do IO link, basically creating, it's like my own serial protocol across here, sending my serial bit streams to the IO link master. And now I can pass 32 bytes of data of whatever I want to pass, whatever the sensor manufacturer deems. So maybe instead of sending a bit, maybe I'm a photoelectric sensor and I want to tell you and I want to measure the distance that you're away. Maybe I'll turn that into an analog value. So I can use the IO link channel to transmit a lot more data than just standard bits of data. So it really opens up and allows you to do a lot of different information can be passed using a single IO and really giving you a universal IO module. Now with this is the concept that the sensor manufacturers wanted. This is the solution that they needed to simplify their lives and to simplify the sensors and the backup of the sensor configuration. Now, Phoenix Contact, we are not a sensor manufacturer. We don't sell sensors. We sell IO modules. We and the other IO manufacturers as a part of this organization said that this is wonderful. This is great because now we can collaborate together, back up your sensors for your configuration, but we can also take advantage of this communications protocol and do a little bit more with it. Let's say we have a situation where, well, I have digital IO modules, I have analog IO modules, but the analog in my machine is usually a lot less dense than the digital. You need an analog point here and there. It would be really nice if I could take analog signals and get them into a universal IO module. Well, IO link's your solution because you can simply get a small adapter for a little $120 adder, a little adapter that actually takes the raw 4 to 20 or 0 to 10 volt signal, converts it to IO link, excuse me, and then transmits it over the standard sensor cable. So I will take this connector, plug it directly into my existing analog sensor that I have in the machine, and now use IO link to transmit it. This is part of that idea where I'm going to do IO link communications all the time, and I'm just going to send a word of data. So now my universal IO module can be a DI, a DO, or an AI, AO, RTD, whatever I needed to do, because I can use these simple adapters to do the conversions. But on top of this is now the sensor manufacturers are seeing this as an opportunity too, because that same sensor that the Bob's sensor company sells in a 4 to 20 milliamp, they are now producing that same sensor with an IO link interface built directly into it so that they can use the concept here where they're doing IO link communications all the time to transmit the data in. So we're able to, using the adapters, we can adapt legacy sensors into the IO link concept, or we can use new IO link sensors and bring that into the fold to get the IO link signals in. Because if you really think about it, IO link, a sensor is taking, let's say example of a float sensor. You're using a float sensor. That float sensor internally has an A to D converter that is taking the float concept and turning it into a digital signal. Then inside of that sensor, you're taking that digital signal, converting it back to a 4 to 20 or a 0 to 10 volt signal to send it all the way to my IO module. Then my IO module reads that 4 to 20 or 0 to 10 volt signal, converts it back to a digital signal to then transmit it up through the serial lines. We're getting rid of all of those A to D conversions because now the sensor manufacturer just sends me the digital bit stream of the equivalent of that value of whatever you want it to be. And that sensor may have the ability of scaling that information for you so that maybe instead of me sending some archaic value of 0 to 30,000 to indicate a 0 to 10 volt signal, maybe it can just send me a digital value of 0 to 100 as a percentage so that it's done. Once it gets through the master and up to the PLC, it's already formatted in the way that I want. And then next, well, what if you need more digital? It's a shame to sacrifice an IO link channel for just a dumb IO link sensor or a dumb sensor that doesn't support IO link. It's a shame to waste a port with this because we have all of this communications we can handle. So what else can we do? How can we take advantage of this communications to expand on this module? Well, we can create IO link devices that are basically concentrators of standard non-IO link sensors. So here we have two IO link devices that are communicating IO link here, and what they're doing is they're taking, let's make this, for example, this is an 8-channel digital input module. We're taking 8 non-IO link sensors. We're taking those digital signals, lining them up and transmitting them through a byte of data to here to then transmit them up. Now this is a low-cost way of adding additional IO off of a single sensor. We're basically using a sensor cable here. We're using a 3-wire sensor cable to bring back signals off of 8 3-wire sensor cables. It's a concentrator of signals, and to simplify it, to get the information back to the PLC. We talked about the master running around 450 list. Well, these little small devices only run less than 200. So for less than $200, I can add an additional variation of digital inputs, digital outputs, whatever I want to put, as long as I'm not exceeding 32 bytes of total data. So it really opens up and changes the way the IP67 IO structure looks, because we're taking advantage of the IO link communications and we're using IO link as a sub protocol to expand on our existing IO to reduce costs, because it's all about reducing costs inside of the system. Here's just a little look at into the background of it. So when you look at the standard digital modules, we talked about the port A and the port B. This is just a simple example of a port A. We're using the 3-wire connections, and the power connection there is enough to supply the power for the sensors. But if I have an output module that I'm tying to this IO link master, that output module needs more power to fire these individual outputs. So it may use a port B connection, so that we're taking that extra 24 volts and that extra 2 amps to supply power to fire the outputs. Now, not all IO link manufacturers are doing the same thing. There are some, while this is a Phoenix example where we combine them both into one, there are other manufacturers that just put a separate connector on there to allow you to supply the output power separately to the device. It really comes down to preference and what you need in your applications, but for this one here, that was the idea behind the type B ports, is to give that extra power you need for your sensor connections. So that's a lot. It is really a truly universal IO module. We could use this, or we do use and promote this into a lot of applications that may not be using any real true IO link sensors or standalone sensors themselves, but are just using this as a new modular I/O concept to reduce cost in their IP67 machine offering. But since the development of this, other device manufacturers are looking at ways of taking advantage of this, and you're starting to see a lot of other products that maybe had Ethernet IP and Profinet interfaces available for them, now coming out with an option for an I/O link interface. The idea behind it is I/O link interfaces are much cheaper than to have put an Ethernet interface in there. So they could reduce their machine cost, their station cost by a few $100s by simply removing the Ethernet port and replacing it with an I/O link port. Here's just an example of a valve bank that might have had an Ethernet IP interface in it. Instead, we do an I/O link interface and allow the master to transmit the data back through and up to the higher level, instead of this being connected directly to the Ethernet network, absorbing a node, and in the end, basically reducing overall cost. So in the end, we're bringing back a little bit of a serial protocol, because down at the machine level, where you're really trying to reduce your costs, we're able to provide this I/O solution at a much lower cost than trying to put everything on Ethernet. Ethernet is really pushing its way down into the machine level, but as you get down to those end components, the cost of Ethernet is still too high for me to just take a sensor cable and put an Ethernet port directly on there. We're moving in that direction. It's not quite there yet. One day they will, and I/O Link is moving to that standard with some of the new 2-wire Ethernet technologies. That'll be a discussion in the next year or two as those technologies come forward. But the other big key thing behind this is this was developed, again, by the sensor manufacturers to come up with a concept to communicate data and communicate to their sensors. This was seen as an IP67 implementation because the sensor cables had M12 connectors on it. They were usually connecting to IP67 modules. But as the technology grew, they saw an advantage to having this and bringing this inside of the cabinet also. This not only allows for the configuration of devices and sensors in the field, but it also enables people to communicate to an I/O device to transmit a lot more data on a lot less lines. So you're seeing that I/O link masters, and this will make a little bit more sense come to the next page. So you're seeing a lot of I/O link masters now showing up in the IP20 form factor to be installed directly inside of the cabinets, because component manufacturers such as Phoenix Contacts and others are realizing we can take devices that we have inside of the cabinet today. These devices have alarm contacts and have diagnostics channels built into these units. But to gain and get all the diagnostics out of them is not always the easiest thing. A motor starter. When you're wiring up a motor starter into your cabinet, you have to wire a 24-volt line to turn the motor on forward. Then you have to wire another 24-volt line to it to make the motor go in reverse. So you fire it one way to run it one direction or another way. Now, these motor starters also have a lot of feedback and a lot of diagnostics. This diagnostics could be digital lines, it could be analog lines. Every piece of diagnostics that this motor starter has, I have to physically wire that back to an I/O device inside of the cabinet. So what do I have? I end up having 5 or 10 wires coming from this device all the way back to different types of I/O modules just to be able to take advantage of all the features that it has. Now, let's get rid of all those connections and let's replace it with one I/O link connection, one 3-wire connection. And now this motor starter can send me 32 bytes of whatever data it wants to send me. I can turn it on, forward, and reverse through that channel, and it can send me feedback as to what's going on with the motor. I could do diagnostics. It can let me know that my motor's wearing. Whatever diagnostics is built into it can be handled directly through that I/O link channel. So inside of the cabinet, we're now replacing 5 and 6 wires with 3 wires, and allowing I/O link communications to allow this information to get back and forth to the I/O link master to the individual sensors. And again, we can back up the configuration of these devices so that if that motor starter needs to get replaced in the system, you simply take it off the rail, snap a new one in, and you're ready to go. Another great example, just to dig into it, is the Phoenix circuit breaker. This is a really cool little circuit breaker. You got the little push buttons in there. You can go through and push the little buttons to configure channel 1 for 2 amps, channel 3 for 4 amps, and go through all of this setup. Or you could use the IO Link interface and do all of that setup through some software utility. And it keeps you from having to go through and push all those buttons. Plus, it allows me to have a lot more diagnostics. It even allows me to go to the point that I can see what every one of these channels, I can see all 4 channels. I can see what ratings they're set to. I can see if the channel is tripped or not tripped. I can read how much current draw is physically being drawn through each of these individual channels. It really opens up data. Data is king nowadays. Everybody wants more and more data. We are in the IoT world, and everybody wants to know everything about everything going. It's hard to say. Wants to know everything. You want all data, and you want it all available to you right now, and I want it easily available to you. IO Link is helping to get that data from these devices in the cabinet through the IO Link master up into whatever system you have, into your cloud system, up to your PLC, whatever applications you have. Here's a great example, some of my poor drawing skills, but you can see we have a little power cabinet. This is a real common applications I see people asking questions about. You have a cabinet, you got your power supply in there. You need to distribute the power and you need to fuse the power into different groups. So what do? You go into that cabinet, you place a couple sets of breakers in there. You can put the IO Link master next to it to communicate with those breakers so you can monitor the current draw on all the individual channels. I now know the draw on every circuit and everything through there. And this is all collected by the IO Link master. Then the IO Link master can transmit this directly up to your cloud service. It could transmit it via OPC, or it can transmit it to whatever PLC you have that needs the information. But when you're looking in the IP20 market, you can't forget about the IP67 devices that are out there also. While I'm in the cabinet and I'm connecting to these devices, I still can also connect to the devices that are outside of the cabinet. So I'm using this to monitor a bunch of circuit breakers. I could also use this as a cabling scheme to use a single sensor cable. So I drill one small hole in the side of the cabinet, take a single sensor cable out into the field, land it on this device, and this device can then pull in 8 or 16 digital inputs off of it. It's a huge wire savings. A wire is copper. Copper is money. You're saving cost. I can then convert analog signals in the field and use, again, a single sensor cable to bring them into the cabinet. One of the biggest downfalls of analog signals in the field is noise. If you take an analog signal and convert it to IO Link right at the sensor, you're sending a serial bit stream through the machine instead of an analog signal. You no longer need a shielded cable. You're saving costs. You're simplifying machine designs, and you're saving cost through the IO Link concept. There's a lot that you really can do with this on top of the idea where it was designed to be a way of configuring your sensor. That was really where it was designed around, is that the sensor manufacturers were looking for an easy way to configure their sensors. Well, that was great, but what they did was they opened up a whole new world of communications to us to allow us to pull every piece of possible information out of these devices, because like anything, every application needs more and more info, and IO Link is allowing these devices to provide it to the PLC easily with simple wiring concepts, reducing the overall concept there. And then the last piece, this is the piece that always gets the biggest hiccups, is the configuration. So not all IO Link masters are configured the same. Everybody kind of does it in their own scheme and their own method. But the main thing to remember is IODD files are there to configure sensors that require configuration. When we go, I'm actually going to drop back. A block like these are just IO blocks. They do their job and they transmit their data. There is an IODD file, but there's nothing to really set. Analog sensors, these are 4 to 20 milliamp converters. They do their job, they transmit their data. There's nothing that needs to be set. Inside of this breaker, there could be, well, I've looked at this one, there could be dozens, two or three dozen different things that I can set and modify the function of the breaker. That I need an IODD file to do that configuration. And how do I do that? IODD files are handled in 3 different methods. You have the idea where you may have an IO link master that does not use the IODD file at all. So what does this master expect? This master expects you to configure the sensor through the manufacturer's specific tools. You set the sensor up, you connect it to the master. The master can still back up the sensor, but it's not using the IODD file integration or IODD file integrated directly into itself. Then you have other masters that take the IODD file and integrate directly, usually into their web interface, so that you can upload them directly into the web page, the integrated web page into the master. Then you can, through the web page, see all the integration or see all the information the IODD file provides, and then go through and do all the settings for the sensor. And then last is you may have a device that uses the IODD file or basically has a separate software utility. You have a software tool that can talk through the IO link device to configure the sensor that's connected to it. And then, but the key thing to remember is once you get through this initial setup of the device, whatever raw data it's going to send, it doesn't matter what master you have, that master will read that data, whether it's 1 bit of data, 1 word of data, or 32 bytes of data. It's all IO link data. That communications is kind of handled automatically. The master talks to the sensor and goes, how much data you have? I have this much data, and it just accepts it and runs. So having IO link there will pass the raw data. The IODD is just that initial configuration of the sensor, and depending on the sensor and where it's needed. This area does add adds some confusion because all the manufacturers handle it a little differently. There is no complete standard saying this is the way it will be done for everybody. We all kind of handle it in different methodologies to provide the connections you need or provide the data that you need to the sensor. But the understanding of the raw data, they all work the same there. It's just this initial setup inside of it. This is an area where I want to come back to in a later presentation to maybe show an implementation specifically for Ethernet IP so you can see how this is done, because every protocol and every PLC manufacturer has their own standardized ways that they've gone to implement that in. But with that, I hope you found that useful. Zach, I'm not sure if there's any questions that came in during that portion. It's a lot of information.
Yeah, I got a couple of them for you when you're done. So,
all right, I threw a lot of information there in a real short period of time, but I just kind of wanted to get the concept of what IO-Link was out and what you can do with it.
All right. So, Jason, during the presentation, when you were going over the IO-Link masters and then the hubs that are just purely IO-Link devices, yep, I had put a link into the chat that was asking or saying if you had any information or anything you wanted to look at further, you could go to our landing page, which is phoenixcontact.com/IO-Link, all one word. There's no dash in the IO-Link. But when I put that out there, I guess it also lists to all the parts that we have. And one question came up is, on the IP67 modules, how do I differentiate between the master and the hub or the IO-Link device? And so I guess the question is, we showed the masters that were there and then the hubs. Which one is which, and how can I tell the difference?
Oh, that's actually a really good question, because this is part of the Phoenix description files that we use when we describe our own devices. One of the things that we do, inside of our descriptions is we start everything with AXLE, which is the product family, and then the next thing we do is we talk about what protocol it supports. If it's IOL, that's the protocol, which means it's one of these devices. If it's a master, it will have, I'm gonna jump back a few more pages if it's a master, it'll say AXLE EIP, so that's an Ethernet IP, and then it's IO-Link on the IO portion. So this is a terminology that's a Phoenix jargon terminology. So that would be the key: is does it start with IO-Link? Then it's just an IO-Link device. If it has a protocol in front of it, EIP for Ethernet, ETH for Modbus, PN for Profinet. those type of things.
All right. Thank you very much, Jason. There are a couple more questions here. There's one. Are you going to get into how you load IODD files into the IO-Link masters? And I believe you answered that right at the end.
Yeah. That I'm looking at separate. And this is a good thing. You can see my email address down here. If you have specific examples you'd like to see, these are areas that basically I'm working on YouTube videos. I'm working on putting more trainings together for you. I have done one-on-one training showing integration into Rockwell for all of our different masters. I can do those for you, but today's training, I wanted to keep it inside of that 30, or I guess I broke the 40-minute mark. So I didn't integrate that into it because it would be too long of a class for this one. But definitely see my email there. Email me which ones you want to see, and I will get back to you.
So I'll say, Jason, we'll set that up as part of our Q2 slate of presentations. So we'll put you on notice for that one.
Okay.
Another one here is, it says, just at a high level, is done via web page served by the IO-Link master, or do you have to use a PC or software package? I guess they're asking about ours specifically.
Okay, so we have, our masters are here. We have 3 different variations. The one in the middle, our IP21, this one has, we basically do all 3 of these options. We have actually, let me start at the top. So we have the top one, our IP67. This does not use IODD files at all. We just connect the devices and pull the raw data from the devices in the network. We'll back up the sensors. We'll do all those basics, but we don't do the IODD file. So we'll expect you to configure the sensor using Bob's sensor software to configure Bob's sensor. The one in the middle uses the integrated web page. So the IODD file gets pulled into the unit, and once it's in there through the web page, it'll actually read the IODD file and kind of create, basically almost creates a custom web page that goes through and shows you all the settings, and then you can change any setting like you're doing through drop-down menus. It's pretty cool. And then the last one, our Axioline, our Axioline F, we're launching a software tool called IO-Link Conf, which is a software that allows us to communicate through any one of our bus couplers, our head stations. So if you have a Modbus, an Ethernet IP, a Profinet head station, it lets you talk through that head station to the IO-Link master that's sitting on the backplane to configure whatever sensors are connected to it. The idea behind this is usually these devices inside of the cabinet have IO-Link sensors that are usually a lot more complicated connected to them, like the circuit breakers and the contactrons. Out here in the field, the IP67 market, usually these sensors are simpler. They don't have as much settings behind it, and the main feature that people are looking for is being able to have our master back up that sensor so that somebody doesn't have to figure out how to turn a bunch of rotary switches to correct locations to get it to work right. So that's my long short answer.
That's okay. Just 2 more questions that we have here, Jason. With the IO-Link master, can we connect 3-wire proximity sensors?
Yes. A standard 3-wire sensor that doesn't support IO-Link can connect to our master. You basically, there is an area in the module where you tell it whether you're hooking a DI or a DO to it. That's it.
Okay, and it looks like the last one, do you have the ability to change overall response time of the entire system, or do you have specified update rates on the master? Is your system limited to its slowest device, or is it the master's update rate?
Okay. All right. Yes, that's
a lot.
Question.
Sorry.
Yeah, no, but that's good. I understand that. So, all right. So the way IO-Link works, you almost have to look at it as here we have. I gotta ask. You can see my mouse moving on the screen, correct?
Yes.
Okay, good. So if you look at this IO-Link master, we have 8 IO-Link ports. Every one of these ports is communicating to their IO-Link sensor under their own individual control. So these are their own individual processes running their updates at whatever speed their sensors allow them to communicate. So this is updating registers internally. Then up here, we have a process where the PLC is pulling the IO device for information and bringing it up. So it's not a wait of, let me get a piece of data, ask this for a piece of data, then this port asks this port for a piece of data. They're all independently running. So maybe we have a 1 millisecond cycle time here. We have a 10 millisecond cycle time up here, so that we know worst case scenario, the PLC maybe is getting it every 11 milliseconds. So they're independent processes that are running all the time. And it's, yes, it is slowed down by the slowest connection, but they are running individually. You don't have to cascade through, if that kind of makes sense.
I think it does. Thank you very much, Jason. Do you have any final thoughts?
No, just that I definitely would want to hear from people on applications that you have, scenarios that you've run into. My email address is here at the bottom, especially implementations in certain environments. I've done a lot of them. I've done some impromptus with customers, and I'm looking at doing more presentations with this, and I'd love to get feedback on which devices, which masters, and what protocols you'd like to see more of.
All right, with that, thank you very much, Jason, and a well done presentation here. Again, you have Jason's contact at the bottom. If you have any questions, feel free to contact Jason about IO Link or any IO opportunities that you may have. I want to thank you all for joining us today. Jason, thank you for keeping it under an hour. It's very much appreciated. And if you missed part of this, or if you want to go back and review some of this, the link that you were sent will be able to be used as a view link to watch it again. So that link will be active, I think, for at least a year to go back and watch it. If you lost the link, then you can just re-register on our 2021 automation webinars landing page, and you'll be able to view any of them there that have already run and sign up for new ones. So thank you all very much for joining, and hope you have a great rest of the day. Thank you.
Yeah, thank you.